Okay, so show that z squared minus 16 is a factor of z cubed plus 1 plus I z squared minus 16 z minus 16 1 into 1 plus I, and hence find the true roots of z cubed plus 1 plus I z squared minus 16 z minus 16 into 1 plus I equals 0. So if something's a factor, it'll divide in equally. So we're going to do z squared minus 0z minus 16, because there's a 0z in there in between, but it's not included, okay? Then we're going to divide that into z cubed plus 1 plus I times z squared minus 16z minus 16 into 1 plus I. Now we're going to see that z cubed divided by z squared equals z times, so we're going to get z cubed plus 0, we'll just say that's plus 0z squared minus 16z, and then we're going to take these away. So when we take them away, we change signs, so minus, minus and plus. The 16z's cancel, and we're going to be left with 1 plus I z squared minus 16 into 1 plus I. Now we have to find out how many times does z squared divide into 1 plus I z squared. So it's 1 plus I z squared divided by z squared, and we see that it goes plus 1 plus I. Now we multiply that, and we're going to get 1 plus I z squared. We multiply z squared by 1 plus I, and then we're going to get 0 multiplied by 1 plus I, so simply 0. Then we're going to get minus 16, which is here, multiplied by 1 plus I. Then we gotta go in, change the signs, that's a minus, that's a plus, and it equals 0. So the fact that it goes in equally means that it is indeed a factor. Now what we can do next is we can change the formula into this. We can change this big formula here. So this big formula, this big cubic equation can be changed into this. It can be changed into z squared minus 16 multiplied by z plus 1 plus I, because the two of them multiply by each other gives you this part here, and that all equals 0. So what we're going to do now is we're going to solve this equals 0. So we're either going to have z squared minus 16 equals 0, or we're going to have z plus 1 plus I equals 0. So we can do difference of two squares for this one. Z plus 4, Z minus 4 equals 0, and we're going to end up Z plus 4 equals 0, Z equals minus 4, and then Z minus 4 equals 0, and then Z equals plus 4. Or we can bring over this to the other side, and we get Z equals minus 1 minus I. Okay. Now what we have next is number 21. And number 21, part of the function z cubed plus 3z squared plus kz minus 8 is shown here. Write down the coordinates of the 2 points where the graph f of z crosses the axis. Okay, so looking at this, we're going to think that it's going to cross the axis. And this is for question 21. We know it crosses the axis here. This is the point 1, 0. Okay, so 1, 0 is the first one. And about here, we can see that the last number is 8. So if you find out what f of 0 is, the y value, when the z value, z is basically x value, equals 0, we would have got 0 cubed plus 3 times 0 squared plus k times 0 minus 8, and then that's going to equal minus 8. So f of 0 is minus 8. So this point here is going to be 0 minus 8. Okay, so here's our 2 points there. Okay, write down the real root of f of z equals 0. Now, remember what I said about these functions. Where they hit the real axis would mean where they have roots. So for example, this curvature here has 1, 2, 3 roots. However, the equation drawn to the right only has 1 root. It only hits the x-axis once, so that's equals z equals 1. Is the real root of f of z equals 0. Find the value of k, where k is an element of n. Well, if z equals 1 is a root, then f of 1, by replacing z with 1, we're going to get 1 cubed plus 3 times 1 squared plus k times 1 minus 8. All that has to equal 0 because the output has to be 0 for this. So we're going to get is 1 plus 3 plus k minus 8 equals 0. Then we're going to get k minus 4 equals 0. K has to equal 4. So now we know that k equals 4. Okay, so this is question 21 and k equals 4. Now we have to express this in a new way. The new way we have to express it is we have to express this cubic function where k equals 4. So k is equal to 4. Just change that to 4 here, so that's now 4z. Okay, so what we're going to do is we're going to get this z cubed plus 3z squared plus 4z minus 8, and I'm going to divide it. Now what I'm going to divide it is, I know z equals 1 is a root, therefore z minus 1 is a factor. Okay, so z minus 1 gets divided into this, so it's going to go z squared times, we're going to have z squared minus, sorry, z cubed minus z squared, change the sign, minus and plus, so we're going to get 4z squared plus 4z, and this is going to go, what we're going to have here, 4 times, so plus 4, so we're going to have plus 4z, that is, so we're going to have 4z cubed minus 4z, once again come down, change the signs, and then we're going to have the 2 down cancel, and we're going to have 8z minus 8, bring down the 8, and then finally it's going to go 8 times, because 8 times z is 8z minus 8, and then you're going to change the sign again, and you're going to get minus and plus, and you're going to get 0. So what we can do here is this big number here, or this big cubic equation, which is f of z, this big cubic equation here is f of z, and this is equal to z minus 1 multiplied by z squared plus 4z plus 8, and that also equals f of z. So this means that a is minus 1, b is 4, and c equals 8. Okay, now the next part of what it wants me to do is it wants me to solve f of z equals 0. So to solve f of z equals 0, what we're going to do is, so we have to use the last part. So what we're going to do here is we're told f of z is 0, so we're going to replace f of z with 0. So this here now becomes a 0. So we're going to have z minus 1 equals 0, because we have two numbers. Technically what's in the bracket is the first number, and what's in the second bracket is the second number, like a black number and a blue number. But when the black number equals 0, because when you multiply both of them by each other, you're told that f of z is 0, so therefore one of them has to be equal to 0. So what we get is bring over the 1, and we get z equals 1. This one here is probably going to be a minus b form, so we have to get z squared plus 4z plus 8 equals 0. A equals 1, b equals 4, and c equals 8. Minus b form is going to be minus 4 plus or minus the square root of b squared, which is going to be 16, minus 4ac, which is going to be minus 32. 16 minus 32 is the square root of minus 16. And then that's going to be all over 2 times 1. As we all know already, minus 16 is 4i, so minus 4 plus or minus 4i all over 2. And then it's going to be minus 2 plus 2i, or minus 2 minus 2i. And they're the other two values of z. Okay, so minus 2 plus 2i, and minus 2 minus 2i. Okay, moving on to the next question, 23. Part of the graph the function is shown here, f of z has two integer roots. Using the graph, write down the integer roots. Well, integer roots is where across the x-axis, so we can see that it's going to be z equals -1 and z equals 3. Show that g of z equals z squared minus 2z minus 3 is a factor of f of z. Well, I'm going to have to divide this in. Okay. Now, just to tell you where we get this from, if I turn this into an equation, okay, so imagine that I can say this one's a factor and also this one's a factor. Well, then when I multiply them by each other, what we're going to get is z squared minus 3z plus 1z minus 3, and then we're going to get z squared minus 2z minus 3. So that's where we get that from, using root a and root b to construct a quadratic. Now if this quadratic divides into the other one here, z4, we can find out that it's a factor because it should divide in equally. Okay, so we're going to divide that into z4 minus 2z cubed plus z squared minus 8z plus 12. Now what we're going to get here is z squared. So z squared multiplied by that is z4. Z squared by 2z is minus 2z cubed. Z squared by 3 is minus 3z squared. So what we're going to have to do here now is we're going to go in and change the signs. So we're going to have minus, plus, and that's going to be a plus. And what we're going to get here is they cancel. We're going to get 4z squared minus 8z plus 12, and that's going to go in 4 times. So we're going to get 4z squared minus 8z. Just 1 second. That's a minus 12. So just make sure you take down the question right. So just get rid of that part there. It's a minus 12. So that's a minus 12. So I'm going to get minus 12 here as well. Then I have to change all the signs when I'm taking them away. So it's minus, plus, plus, and then we cancel, 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 and we get 0. So we just have to prove that this full equation now turns into this. So this big z to the power 4 equation is actually the same thing as this. So it's the same as this part here and this part here. Okay, so the full thing, underlined in green, is this here. Now to find the roots, f of z equals 0, so the full thing equals 0. We already have solved this, and what we get is our two real roots. We get z equals -1 and z equals 3. Now we have to solve this one here, so we're going to get z squared plus 4 equals 0. We're going to get z squared equals -4. Z equals the square root of -4. So z equals 2i or -2i. Alright guys, so that's 19, 21 and 23.